Hello juniors, today we're going to be working with electronic assignment 18, which is modeling periodic functions. We're going to see how periodic functions, which are mainly sine and cosine functions, apply to real life situations. How can they be used to model different situations in real life? Okay, so before we start, I wanted to show you a little bit about the tangent function, which is another function that may appear in the IB exams, right? So to understand a little bit how this tangent function looks like and its characteristics, we're going to read the following. So this is a graph of the tangent. If we plot the tangent function, you would see that it has this shape. You see that it's very different from sine and cosine function, which are waves, right? Actually, tangent functions are also waves, but they look like this, okay? So let's read the characteristic. It says, like the sine and cosine functions, the tangent function is periodic. It repeats. You see that it has waves that repeat through time, right? There are vertical asymptotes at value of x where the function does not exist. You see that, for example, this line is a vertical asymptote. It's a line that the function never touches, or maybe this one over here, this one over here. So you have infinite vertical asymptotes throughout the domain. It says the same cycle of values repeats between each pair of vertical asymptotes. The period of the tangent function is 180 degrees or pi radians. So this is a very important difference you should consider when working with tangent. Sine and cosine both have a period of 2 pi, while tangent function has a period of pi only, pi radians. So unlike the sine and cosine functions, the tangent function does not have an amplitude. You see that we cannot measure the amplitude here because the sine goes from negative infinity to positive infinity. So there's no amplitude. And then it says it has no maximum or minimum values. If it has no amplitude, then it has no maximum or minimum values. So these are the basic characteristics you should know about the tangent function. So this is an example which I have solved already in order to save some time. It says solve the equation tangent of theta equals 1 minus theta for this domain. Okay, give your answer to 3 significant figures. So to solve this problem, a quick way to do it, if you are allowed to use calculator, is to graph this, right? Tangent of theta equals, as one function we would graph tangent of x, right? Because in the calculator we should put tangent of x instead of theta. And as a second function, we're going to put whatever we have on the other side of the equation, which in this case is 1 minus x. So if you plot this and you restrict it to this domain, you may try that in your calculator if you want, you will get a sketch like this, right? This is the red are is the tangent function, while this line over here is this straight line over here, 1 minus x. So if it says solve the equation, we need to find all of the points of intersection, right? So here we have one point of intersection, another point of intersection, another point of intersection, and so on, okay? So these are all the different solutions of this equation, right? So if you put in your calculator, shift G solve intersect, you're gonna be getting all of these points of intersection over here, which correspond to these 5 results over here, okay? So all of those answers are possible answers for this particular equation, okay? So that's how you solve this using the calculator. It's quick and it's easy. So a brief summary of what we have seen up to now about the 3 main functions you should know for the IB exam: sine, cosine, and tangent. Remember that the origin of each function, for example, sine of x is 0, 0, cosine of x starts at its maximum, which is 0 and 1, and tangent of x, if you take a look at this graph, tangent of x also as sine of x begins at 0.00. Okay, then the period for sine and cosine, the period is 2 pi, while for tangent the period is pi. And finally, if you consider the amplitude for both sine and cosine is 1, and for tangent there's no amplitude, okay? Remember, all of this analysis is done considering the parent function, right? The function without any type of transformation. So these are the characteristics that you should remember. Okay, so for today's class, we're going to see this, modeling periodic functions. The objective is to model with sine and cosine functions. So these are some real-life situations that can be modeled using either sine or cosine functions. These are very interesting topics. You might want to think about them for the math internal assessment, right, for the project. For example, analyzing tide heights in the sea, or sunrise times, average temperatures, cycling mechanism, which by the way is this video is about that. If you want to take a look at this video, I'm gonna attach this video to the electronic assignment as well. Then the Ferris wheel, that's the game we have in the parks. Sound waves, this I told you that one student did an internal assessment about this topic. Then heat waves, and finally the lunar orbit. These are all examples of periodic functions applied into real life situations. Okay, all of them are very interesting to analyze if you want to make models of this for your projects. Okay, so here's the video. I'm gonna let you see the video later on to avoid wasting time for now. But it's a very interesting video where some students consider riding their bikes, and then they model the mechanism of the bike as a periodic function. Then it says, to create a cosine function model for data, you need to know either cosine or sine, either one. You need to know the amplitude of the function, you need to know the vertical translation, the horizontal translation, and the period. So these are things that you already know from the previous class. Then it says, the sine function has the same amplitude, vertical translation, and period, but its horizontal translation is 1/4 of the period to the left of the cosine curve. Okay, so all of this amplitude, vertical translation, and period are all the same for sine and cosine function. The only thing that changes when you're modeling with either sine or cosine is the horizontal translation. So that varies depending on the function you pick. Okay, so let's do this investigation. It says the London Eye. The London Eye was the 4th largest Ferris wheel in the world when it was built, with a diameter of 120 meters. One full rotation takes 30 minutes. So imagine if you get up to this Ferris wheel, it will take up 30 minutes for you to complete the rotation. And you board from a platform which is 2 meters above the ground. So as you can see here in the picture, here's where you board, right? And you are on a stand which is 2 meters above the ground. And then this has a diameter of 120 meters. That means that when you go up, you are going to be here at 122 meters of height, right? And you're going to take 15 minutes to get to the maximum point, and then 30 minutes to complete the full rotation. So it says, can you find your height above ground as function of time in minutes? So let's see how we can model this situation using the concept of periodic functions. It says, what real-life situation can be modeled with graphs of trigonometric functions? Okay, we already mentioned that before. Then number 2, how can you solve real-life problems using graph of trigonometric functions? We're going to see that right now. Number 3, as you write, what stays the same and what changes? Discuss answers with a partner. Okay, so what do you think stays the same when we analyze this? Maybe we could say that there's no displacement here. I mean, the wheel doesn't move, right? The wheel is always staying here. The only thing it's doing, it's rotating, right? So we could say that the displacement of the center of the wheel is remaining constant. It's not moving. And what's changing? Well, what's changing is my height, first thing. Then maybe the angle of rotation is changing. So those are some things that change here, right? Number 4, how high above the ground would you be at the start of the ride, P0? At P0, which is this position over here, at what height are we? We are at 2 meters, right? So P0, let me write that here. P0, our initial position, is equal to 2 meters in this situation. Then, what is your maximum height, P6, above the ground during the ride? So if we take a look at P6, which is above here, what is the height here? The height would be 120 meters plus, don't forget about this, plus the 2 meters of the initial position, right? So at P6, we're at 122 meters. P6 equals 122 meters. That's the maximum height. Then it says, how many minutes would it take you to get to point P6? If the problem is telling us that the full rotation is done in 30 minutes, then getting up to P6 would be half of the time, which is equal to 15 minutes. So let's write here 15 minutes. Then it says, how many minutes would it take you to get P3 and what would be your height at that time? P3 is right here, okay? You see that P3 is half of the Ferris wheel, right? So if it took me 15 minutes to reach P6, then the time it would take to reach P3 would be half of 15, so it would be 7.5 minutes. And what about the height? If the height for getting to P6 was 122 meters, then the height for reaching P3 should be half of that, right? It should be 60 here plus 2, which is 62 meters, right? Yes, all of this is 120. Half of that would be 60. So here we're 60, but we need to add this 2 right here. So we are at 62 meters. So this would be position 3 is equal to 62 meters. A common mistake is that students tend to divide this by 2. But if you divide that by 2, you are going to be getting as a result 61 meters. But actually it's 62 meters, because the only thing that we're halving is this 120 over here. We do not have all of the distance, we just have the diameter of the circle. Okay, so that's something you need to pay attention when working with this. Then it says, how many minutes would it take you to get to P9? Where's P9? P9 is right here. And what would be the height at that time? Okay, so P9 is basically, the time it would take is 15 minutes plus 7.5, right? So that would be 15 plus 7.5, that is equal to 22.5, right? 15 plus 7.5, yes, 22.5 minutes. And what would be the position of P9? We see that the position is actually the same as P3, right? We're in the same diameter. So the height is again 62 meters, P9. Then it says, copy and complete this table. Okay, so let's do this. Copy and complete this table. We already know P3. P3 occurs at time P3. Where's P3? 62. And not 62, 7.5. And the height is 62. We also know P6. We know it's 122 meters, and the time would be 15 minutes. And we also know P9, right? 62 meters in height and 22.5 minutes in time. And that's everything we know up to now, right? Yes. How can we find these intermediate values, right? They're a little bit more difficult because they're not special positions, right? Such as P0, P3, P6, and P9. So in order to find those intermediate values, we would have to find the trigonometric function that models the Ferris wheel. So let's see. How can you model periodic behavior? It says. Then it says, use graph paper to plot these points and draw a periodic function to model your journey on the London Eye. Okay, we're going to skip this part because the most important thing I want to do with you is the model. We're going to do the model, and with the model, we are going to find the rest of the values, okay? One way to maybe find the time, at least, of, the time, let's see. One way to find the time for each of the positions is to divide the number of pieces we have in the Ferris wheel. How many pieces do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, right? That means that if we divide one full rotation, which is 30 minutes divided by 12, it means that for each piece, let me do this here, each position takes 30 minutes divided by the number of pieces, which is 12, and this is equal to 2.5 minutes to reach. That means that if we're at 0, our position 0, which is time 0, to get to position 1, we're going to take 2.5 minutes. So we're going to get 2.5 minutes. For position 2, we need to add up again 2.5 and we'll get 5, then plus 2.5 and it's 7.5, and so on, right? It would be 10 then this would be 12.5, 15, then 17.5, then plus 2.5 is 20, then we have 22.5, then we have 25, and finally, for P11, we're going to have 27.5. And if we move one more, we're going to get back to P0, and that will be at 30 minutes, right? Okay, so the problem then is to find these heights, okay? So to find those heights, it's better if we first find the model, and then after we have the model, we're going to calculate those values. So let's go to part 12. It says exercise 12. Find the amplitude, period, and vertical shift of the curve. So how can we find the amplitude of this situation? If you take a look at the table here, we know that the minimum value occurs at P0, right? Let me do this with a different color, maybe blue. This is the minimum value, while the maximum value occurs at P6, right? Which is right here. So this is the maximum value. So how can we find the amplitude if we have both the maximum and the minimum value? We can apply. We know that the amplitude should be half of the distance between the maximum and the minimum point. So let me see if I can do that right down here. I'm going to add 12. We're going to say that the amplitude is found by performing the maximum minus the minimum. That's the distance between both. Minimum. And we need to divide this distance by 2 because it's half of that distance. So it's 122 minus 2 divided by 2. This is 120 divided by 2, that's 60 meters. So this is the value of the amplitude, right? That means that the value of A would be equal to 60. This is one thing we already know. Then it says, find the period. The period is how long it takes to complete one full cycle. So if we start at here, we're going to end up at here right after 30 minutes. That means that our period is equal to 30 minutes. So let me write that here. Period is equal to 30 minutes for this situation. So if we have the period, we can find, for example, the value of B, right? We know that the period, let me do this here, period is equal to 2 pi over B. So we're going to have that 30 is equal to 2 pi over B. So then the value of B would be equal to 2 pi divided by 30, and that is, if we simplify, pi divided by 15. Okay, I'm simplifying this already. So we have the value of A, we already have the value of B. Then we want to find the vertical shift. Is there any vertical shift? Yes, there is. If you take a look at the graph, the vertical shift would be right here, okay? And because we have the minimum value right here and the maximum value right here. So the axis of the periodic function must be in the middle, right? Halfway between the maximum and the minimum point. So what distance is this over here? We know that the distance, according to this graph, is 62 meters. Or you can just look at this and it's 2 meters plus 60 and we get 62 meters. So the vertical shift, or the axis, would be vertical shift, vertical shift is equal to 62 meters. That means that the value of D is equal to 62. Okay. Finally, we need to find the value of, we don't have any horizontal shift, so the value of C is equal to 0. Okay, I'm gonna write this here. Horizontal shift is equal to 0. That means that the value of C is equal to 0. Okay, so once we have all of our values, now we can write down the full equation, right? Let me write this in red again. The full equation that describes this periodic motion would be, we still need to define whether it's a sine or a cosine function. You see that we're starting at the minimum point. If we're starting at the minimum point, we should consider a cosine function, right? The cosine function starts either a maximum or a minimum. Actually, the original cosine function, the parent function, is always starting at its maximum. So if I put a negative sign in front of the a, in front of the value of a, then I will be reflecting it on the x-axis, and this cosine function will be starting at its minimum point. So we could say that the function, the model, is this is h of x, right? Yes, height with respect to time, actually, is equal to negative 60 in order to make sure it starts at the minimum point, times cosine of b is pi over 15. There is no horizontal shift, so pi over 15x, so not x, t, because it's height with respect to time, plus 62. This is the model, or the equation that models, or the function, sorry, that models the Ferris wheel described in this situation, okay? So with this model, now we can find all of the other values to fill in our table, okay? So let me show you how you can do that. Let me see if I can. There we can see the function, and we can see the table. So if you take a look at the calculator now, we're gonna go to menu graph, and we're gonna, let me erase this, we're gonna plug in our model, right, which is negative 60 times cosine of fraction by over 15 times x plus 62. Remember that 62. Remember that whenever we're working with trigonometric functions, we should have our calculator set up to radians. So shift menu, make sure that it is set up in radians. Angle says radians, so that's fine. So once we have plotted the function, we're going to draw this. We need to change the scale. We're going to go to shift win. We see that in our example, the minimum value of x is 0, while the maximum value of x is 30. Let's write 30 because it's one full rotation, so 30. Scale, we could go from 2.5 to 2.5 according to our table. So 2.5 we could write as a scale. Then the minimum value, according to this, is 2, but I'm going to write 0 just to visualize this. And the maximum I would write 122, but I'm going to put 122, that's fine. Then the scale for this would be, we could make this equal to 10, right? So now we're going to draw this, and we should be able to see this is exactly the behavior of any person in the Ferris wheel, right? It starts at 0 height, and then it goes up, it reaches a maximum point at 122 meters after 15 minutes, and then it goes down up until it reaches its original position. If you take a look and we see that, and we look at the maximum point, for example, we should have 122 and 15, right? You see, y is equal to 122, which is the maximum height, and that occurs at exactly x equals 15 minutes, okay? So this model is correct. Now, we need to fill in the rest of the values in our table. So we're gonna go to menu, table instead of graph. We have the same function here. We're going to see if our set is correct. We're going to start at 0. We need to end at 30. Our step is 2.5. So once we have this information, we're going to click on table. And here we have all the values. P0 starts at 2. Then P1 is 2.5 in time, and here's the height. I'm going to fill in here. This is 10.0. I'm going to write 3 significant figures, so 10.0, actually 2 decimal places, so 0.4. 0.4 is fine. Then we already have P2, we already have P3. Then P4 occurs at 92 meters, and we have P5, which is 12.5 and 113.96. Then we have P6, which is the maximum height. P7, which again are repeated values, you see, 113.96. Then P8 would be, what happened here? P8 says 103.25. I think that's a mistake there. Okay, Then P9 says 62, P10 says 32, and finally P11 says again the same value as P1, which is 10.04. And if we go to P12, you'd see that it's again 2. So it's back to its original position, okay? So you see that the whole table is symmetric, right? P0 is the same as P12, P1 is the same as P11, P2 is the same as P10, and so on. So it's symmetric because we're talking about periodic functions, meaning that the values repeat with time. Okay? So I think that's it. No, we have model function, then it says check your model by finding your height after 15 minutes. We already did that and we got the maximum height. Then what kinds of information can be modeled using periodic graphs? We already discussed that. The best picture of Big Ben take after 18 minutes of London Eye. Okay, this is just to discuss. What equation can be solved using trigonometric function? We already discussed all of this. Okay, so that's it for this investigation, juniors, and I'm going to leave the class here to avoid making this video too long. So in the next tutorial video, we're going to see more examples about how we can model with trigonometric functions. But I hope this was clear. If not, please let me know. Remember, this is a very interesting topic for the internal assessment if you want to consider this, okay? So let me know if you have any doubts, juniors, and see you later.